The spire at the top of Burj Khalifa seems quite small. Neither is there permission for the public to go up there, nor are the floors in it largely occupied. But the importance of this spire in the Burj Khalifa is such that without it, the integrity of the entire building could be compromised. Creating it was a necessity for the engineering team, and completing this task was crucial. This spire of Burj Khalifa is no less than a skyscraper in itself. The height of just this spire alone is more than many skyscrapers in over half the countries in the world. Made from 4,000 tons of steel, this 244-meter tall spire has a top antenna alone weighing 350 tons. If this entire spire were removed, the height of Burj Khalifa would decrease by 30%, leaving it just 585 meters tall. This is the height where the last floor accessible to the public, the 154th floor, is located. Above this, the spire begins and goes up to the tip of Burj Khalifa. Floors from 155 to 163 have been constructed. But you might be surprised to know that these floors are not at all habitable, because during strong winds, the entire spire can sway up to 6 feet. Yes, this is not a flaw, but rather an advanced feature of the spire. Dubai's location is such that on one side is the Arabian Gulf, and on the other side, the Gulf of Oman. Strong sea breezes are a common occurrence in Dubai. And at the height where the top of Burj Khalifa is, the speed of these gusts can easily reach 240 kilometers per hour. This spire absorbs the pressure of these winds within itself, swaying up to 6 feet to keep the 154 floors below it safe. American structural engineer William Baker was the first to create such a design for Burj Khalifa that doesn't stop the winds but literally confuses them. When strong winds collide with a structure, energy is generated. This energy must be released somewhere. The 154 floors of Burj Khalifa are connected with a main buttress core. If this energy were to be released into this main core, it could cause cracks in the concrete. That is why the spire is not connected with the buttress core, but is made from a steel structure. As you may know, steel is a flexible metal. The energy generated from the winds is released into the steel structure of the spire, causing the top of Burj Khalifa to sway. The engineers have designed it in such a way that it can sway only up to 6 feet. The spire of Burj Khalifa doesn't just make this single sacrifice. The device mounted on the spire also protects the entire Dubai from dangerous lightning strikes. The device at the top of the world's tallest skyscraper is a lightning arrestor. It has a small sensor that detects active charges in the surrounding clouds. The lightning arrestor generates an opposite charge, attracting the lightning towards it. Then, through a steel wire, it safely channels millions of volts of charge, protecting the entire building, and discharges it into the ground. Since the lightning arrestor on the spire is higher than other buildings, it not only protects Burj Khalifa, but also the whole of Dubai from millions of volts of current. So far, this lightning arrestor has perfectly performed its function 16 to 20 times. After each lightning strike, a small battery in it needs to be changed, which requires going up to the top of the spire. Dubai has been subjected to sandstorms and strong winds, with speeds reaching up to 100 kilometers per hour at ground level. Such strong winds are a significant problem for tall skyscrapers. Near New York City, in Midtown Manhattan, there is the Citigroup Center, only 279 meters tall. After its construction in 1978, a major engineering flaw was discovered in its design. An engineering student from Princeton University noticed that the Citigroup Center would not be able to withstand the load of strong winds. Just 25% of the force from strong winds could easily topple the Citigroup Center. When this flaw was brought to the attention of the building's designer, they immediately did some calculations and agreed with the engineering student. It is said that this issue was kept a secret, and extra dampers were added to the building under the guise of maintenance. This fact was not disclosed for many years. When strong winds collide with any building, they create rotors on the building's backside, known as vortices. These vortices are pockets of low air pressure that sway the building sideways. Once a building starts to sway even slightly, these vortices significantly amplify the movement. A perfect example of this is a swing in a park, which most of you might have used at some point. If you move your legs in sync with the swing's movement, the swing naturally goes higher. This is because your legs are moving in resonance with the swing's frequency. This phenomenon is known as resonance. In the case of Burj Khalifa, the world's tallest building, Structural engineer William Baker designed it in a way that confuses the winds. If you notice, all the decks of Burj Khalifa are not built at the same level. Instead, they are built asymmetrically, meaning each deck is different from the other. As a result, when wind collides with Burj Khalifa, the rotors or vortices generated behind each floor are also different from one another, meaning their frequency does not match the tower's frequency. This is why the world's tallest building has been standing safely for the past 13 years, regardless of whether the wind comes from the west or the east. The design of Burj Khalifa confuses the wind from all directions. Normally, before starting any construction project, its complete design is prepared in advance. However, during the construction of Burj Khalifa, nobody knew exactly how tall the tower would be. Initially, its proposed height was 530 meters. This is because in 2003, when the construction of Burj Khalifa began, the construction of Taipei 101 in Taiwan was in its final phase. Taipei 101 was set to have a height of 508 meters, so the plan was to make Burj Khalifa 530 meters tall initially. However, it was later thought that the world record of 530 meters could easily be broken by someone else. Therefore, during the construction of Burj Khalifa, it was decided that the actual height of the tower would not be disclosed until the construction was complete. MR Properties kept the world in confusion until the end. In 2003, it was announced that Burj Dubai, which was the original name of Burj Khalifa, would be 530 meters tall. In 2004, it was stated that it would be extended to 570 meters. In 2005, this was increased to 710 meters. In 2006, to 800 meters. And then again in 2006, it was stated to be 818 meters. Finally, when the construction was completed, it was stopped at 828 meters. This was the reason why other projects proposed during the construction of Burj Khalifa, even those taller than Taipei 101, could never claim the title of the world's tallest building. Due to these variations in Burj Khalifa, MR Properties, who initially proposed this project, faced financial problems. This was because the budget they had set was being exhausted as the height increased. Then, the ruler of Abu Dhabi, Sheikh Khalifa bin Zayed Al Nahyan, funded the project, reviving it. This was the point when the name was changed from Burj Dubai to Burj Khalifa. After Burj Khalifa, many projects were announced and construction started in the race to claim the title of the world's tallest building. But so far, there seems little hope that this title will be taken from Dubai. The construction of Saudi Arabia's Jeddah Tower has been stalled for several years. Kuwait had planned to build a 1-kilometer tall building named Burj Mubarak, but there have been no updates since the plan was announced. Even Nakheel Properties had launched a project in Dubai named Nakheel Tower, which was said to be over 1,000 meters tall. Construction began, but was halted after a year. The total cost for Burj Khalifa was $1.5 billion. Today, 8,000 to 10,000 tourists visit Burj Khalifa daily. If we calculate just the average entry fees, Burj Khalifa earns over $1 billion a year just from ticket sales.